I'm joined on today's call by my colleagues Andy Schaffner and Lee Adamson, who are going to take you through the main content of today. So for now, I'm going to pass you on to Lee, who's going to take you through an introduction. Once again, thank you for joining. On to you, Lee.
Thank you, Michael, and hello and welcome to today's webinar around Solid Edge Cam Pro. Thank you all for joining us today. I'm Lee Adamson. I'm Business Development Manager for Manufacturing here at 1PLM, and I'm joined by my colleague, Andy Schaffner, who is our Technical Manager. Now, I will be passing over to Andy shortly, but I just wanted to take you through an introduction about the webinar today. So what we'll be looking at today is the Solid Edge Cam Pro 2.5 axis milling. So I'll be asking why we're doing this today and what are the benefits to you. Well, since Solid Edge 2022 release, you can now get the 2.5 axis milling package included with your licenses. Now, I will talk a bit more about the licensing a bit later on today, so we'll cover that. So what are you getting within the software and the benefits of having this? Well, it's a package that will work with single components. It'll also work with an assembly of components as well. Now you'll be able to take in the solid edge data and the PMI. So technology built into that, threading data, etc. within the file will be transferred through into the CAM environment and can be used using that technology that's built into the CAD file. It will also maintain associativity to any model changes, so making revisions very seamless and straightforward, working between the Solid Edge and the Cam Pro. If you are getting files from other sources as well, it does work with all the sort of CAD format types. And there is a library of post processors ready and available through the Post Hub. Now, I won't talk too much on that because Andy's going to take us through that through his demonstration. And then finally, this is the 2.5 axis milling package, but there is ability to grow this with the needs of the business. So it will grow. There are other modules available. So what do you get available to you? Well, it is a fully capable 2.5 axis milling CAM package. Now, this is 50 years of CAM development, so we know it's robust and it's a reliable system that will work. And it's developed to work with Solid Edge. And as I said earlier, there is a great upgrade path. So if your discipline change within the CNC environment, you can upgrade this accordingly. You can go up to 3-axis, 5-axis turning, and even multitask machining with the available modules on top of this package. But today, we're going to talk more on the 2.5 axis milling. So the journey begins here. I'm going to pass over to Andy. He is now going to take us through a bit more information and also a demonstration of the product. And I will speak to you a bit later on. Thank you.
Okay, thank you very much, Lee. So what we have here is an image of Solid Edge Cam Pro, which is Siemens's standalone CAM solution. Now actually, when I say standalone, it's actually a standalone version of NX CAM. So NX CAM is obviously part of the NX suite, which includes NX CAD. And what they've done is they have taken the NX CAM part of NX and created a standalone version which is Solid Edge Cam Pro. This has got all of the same functionality in it as standard NX. So the normal NX product, all of that functionality is in Solid Edge Cam Pro. So what you're being offered with a 2.5 axis milling is all of the same very, very powerful functionality as you get with NX Cam. It's in no way stripped down or anything like that. So let's have a quick look at what you actually get as the full Solid Edge Cam Pro and how it all sits together. So obviously what you have got with Solid Edge is 2.5 axis milling. And that's obviously only part of the Solid Edge Cam Pro suite. So obviously you can do turning, you can do 3.5 axis milling, 5 axis milling, mill turn, so complex mill turn, upper turrets, lower turrets. Do on machine probing, wire EDM, and we've got full-blown G-code machine simulation integral to NX Cam or Solid Edge Cam Pro itself. So what's the difference between 2.5 axis milling, 3 axis milling and 5 axis milling? Well, quite simply, let's go to the 5-axis first of all. When we talk about 5-axis, we're actually talking about 5-axis simultaneous. So the ability to be able to rotate the X, the Y, the Z, and 2 rotary axes at the same time. 3-axis milling, this is more to do with mould and die surface machining, where you're looking to scan faces of the parts, whereas 2.5-axis milling is looking at prismatic parts which are effectively got straight walls, maybe tapered walls, but they're straight tapered walls, for example. So parts which aren't for mould and die kind of work. Let's take a look at what you actually get within the 2.5-axis milling license. Obviously you get, well, not say obviously, you get prismatic roughing, prismatic finishing, hole making. It's worth pointing out that although we're talking about 2.5-axis milling, it doesn't mean you can only use a 3-axis milling machine. It's actually be able to do multi faces, multi-plane. So if you've got a 4-axis machine and a tombstone, you could machine on multi faces of the part. And indeed, if you've got a 5-axis machine that you use for 3+2 positional work, absolutely, it will work on that as well. So we're not just talking about 2.5-axis as far as the parts are concerned. You can do multiple faces all within the same part. Going back to the prismatic roughing, what's actually included with the roughing is the highly efficient adaptive milling toolpath. This in itself is a reason to be using the Solid Edge Cam Pro 2.5-axis milling. The fact that you get this adaptive toolpath. So anyone that's got an old style cam system that basically roughed out the pocket by doing what we used to call a boundary collapse method down to the center and then like morphing the toolpaths out. The new style toolpaths, they're looking at volumetric material removal, so actually keep the load on the tool constant throughout, so you can up the feed rates and improve the tool life. Absolutely brilliant toolpath in its own right. It really is somewhere that everyone should be going to, adaptive milling. So we've got full tool path verification and an analysis of the in-process workpiece, so you can analyse how much material is left. And also we've got a whole raft of CAD tools available to us. We've got the full sketching, we've got synchronous modelling, the same as you have in Solid Edge, and we've got full assembly modelling. Let's just go and have a look at some of the toolpath bars actually before we get into our live demonstration, just to see what we've actually got. These are the 3 main ones that I would think that you'd be wanting to be using at any time. So clearly the ability to be able to create tools, create geometry and create operations. If you look at down the far end, there's also the ability to do automatic feature recognition and automatic toolpath generation based on knowledge-based machining, and we'll take a look at some of that going forward. We've also got the toolpath animations to be able to do verify what's going on. Design tools. Or quite simply, we've got the synchronous modelling, so you can do push me, pull you, delete faces, delete holes, all the kind of manipulation that you might want to do. You can extract surfaces and edges, you can grow edges, pull edges, do all kinds of little twerks that you might need to do just to help you with some of those complex parts. We can also patch holes as well, and there's loads of other clever stuff that we can do in those design tools, including we've got the sketch tool here. This is the full proper sketch tool that you have in NX CAD for all the CAD designers that are doing sketching and extruding models. This is the same sketch tool as you get in CAD. And you can use that wireframe geometry to actually create toolpaths. So the toolpaths inside Solid Edge Cam Pro, you can drive off wireframe geometry, you can drive off the edges, you can drive off the full model, and you can drive off faces of the part as well. So the flexibility is all there. And then we've got the assembly tools. So this is where you could actually bring in additional fixtures, additional clamps, bolts, and assemble it all up inside the Solid Edge Cam Pro environment. Personally, I would actually do my assembly inside Solid Edge. I used to have a seat of Solid Edge and the Solid Edge Cam Pro. It used to be called Cam Express. I had it when it was called Cam Express, but again, that was fully blown NX Cam, which is exactly the same. I used to build my manufacturing assembly, so I used to build my part into the stock, into a vise or a fixture in Solid Edge, and then pass that across to Cam to do all of the programming, and then I used to make a setup sheet inside Solid Edge as well. It worked perfectly. So although we have the assemblies toolbar here, I very rarely used to use it. but the functionality is there. This is the full assembly modelling that you get again inside NXCAD. So the tools that are available to you here are really powerful. You've seen the PowerPoint enough. Now let's go to a live demo. Okay, so here we are in Solid Edge. I've got my part, as I said. I've got a component. I've drawn it in some material, and I've put the material into a vise. All I need to do is launch the Cam Pro button to launch that into Solid Edge Cam Pro. To see that actually happen, what we're going to do, let's just jiggle this around to one side for a second. Okay, we'll just move that to there. No, actually, I can't move it to there because it disappears. Just move that to one side. If I press the Cam Pro, quite simply, we will see it launch into Solid Edge Cam Pro. It gives me a little bit of information about what's happened. Quite simply, it's all in there, and say OK, and there's my Solid Edge part now in Solid Edge Cam Pro. And what we could do is we could go into applications, and we could go and select manufacturing, and we could start machining at this point here. What I would suggest, and the way I would work, is actually not to actually start machining in this part, but actually go to File, New, and actually use one of the templates. By doing that, you're able to create a new part which has already got some toolpaths assigned, maybe some tools are already there, and what that means is that you haven't got to start with a blank sheet of paper every time, so it makes programming a lot easier. I've actually created my own template here that's got a number of different machine tools in, with all toolpaths and everything already set and ready to go. I've got a turning one here because, to be honest, if I'm doing turning, I can't remember a part that didn't have facing, rough turning or rough boring, finish turning or finish boring. So I've got all those operations with all those tools, all the tools sat in the turret just ready to go. But 2.5 axis milling, again, although I've got a machine here, it doesn't mean I have to do full machine simulation, but it is nice to see the fixture on the machine to actually get a full, proper digital twin idea of what it's going to look like when it goes down to the shop floor. We're not going to do that today. I'm going to try and work as near to possible as you're going to get this out of the box. So I'm going to use the general setup. I have to admit I have created a few toolpaths ready to go inside here. Very easy to do yourselves. Okay, so we're going to go for the general setup. I'm just going to say OK. And quite simply, it sets up a new part file for us, and this is an assembly. So the component is an assembly. The assembly that I brought across from Solid Edge is now a component of this new assembly. And this is how this associativity is being maintained throughout. What we're going to do is we're going to first of all identify what the stock is and what the workpiece is, what the final part is that needs to be machined. Let's just first of all go to the manufacturing tab, and we'll have a quick look at what's actually going on. We saw this before on the PowerPoint slide actually. So we're in the home tab, so we've got, obviously we can define tools, we can create geometry, we can create the operations, the knowledge-based machining down the end here. So it's exactly the same as we saw on that image. But down the side here, the operation navigators, and so there's 3 different ways of kind of viewing what's going on. There is the program order view. This is the order at which the program will be posted to the machine. There's a machine tool view, and in fact if I go into here and expand all, here you'll see all of the different tools that we've got available and all the different tool paths that are sat underneath it. So it's very easy in fact to go and take one of these tools paths and just drop it onto a different tool if we wanted to. And finally we've got the geometry view, and this is where we'll first do our setting up of our part. Okay, so what we're going to do is let's go into the workpiece. Let's go and select the blank. We'll select the blank from the screen, and if I just go into my assembly view, we'll turn off the blank now because we don't need it. Quite simply we'll go in and we'll select the part as well. Okay, so we've defined the part, we've defined the blank it's going to be machined from. I'll go and select the datum now quite easily. I'm going to go into here, and in this particular case I'm going to actually use 3 planes, and I'm going to say I'm going to go from that face there is my X plane, that's going to be my Y plane, and that quite simply is going to be my Z plane. So you can see I've put my coordinate system in fresh air, the intersection of those 3 planes. I'm going to create a clearance plane, and I'll make that 50 millimeters above the job, and that's where the tool is going to go to before it comes towards the job and when it goes home for a tool change. And that's it. My job's set up, ready now, ready for applying the tool paths. But before we do that, let's go and have a look at the tool paths that we've actually got available to us. If I go back to the Home tab, let's go and have a look at the Create Operations. First of all, there's a whole raft of different operation types available to us in here. But before we do that, let's just go and have a look at mill planar. These are all 2.5 axis milling operations. So we can either pick faces, we can pick walls to automatically machine the part, and all of these are looking at the in-process workpiece to make very economical tool paths. We can also select the wireframe edges of the part to actually, so curves and edges or the wireframe sketches, to actually program from those. And we can also do things such as identify grooves and machine those. And finally over here we've got the ability to be able to identify all of the edges and very, very quickly put deburring onto them. So these are all 2.5 axis milling operations. If we move down to the next one, mill contour, this is actually broken up into, these ones at the top can be used by everybody, so they're 2.5 axis milling operations, but they could be 3D milling operations depending on how you want to use them. But then the final ones, the final 3 rows of these, or two of these rows here, these are realistically 3 axis milling operations. So these are for surface machining, more free-form type complex geometry operations. So looking further down, we've got the multi-axis, so these are the 5-axis operations. But finally we've got hole making holes, so drilling, tapping, boring, thread milling, boss milling, anything to do with holes, all of those are all available to you in the 2.5 axis milling. And finally we've got probing. We've got our own probing routines that we've written for doing corners, bosses, slots, webs, etc. All really easy to use, and there's another webinar that you can watch on that. Okay, so let's just go and have a quick look at what we could do. So the easiest way of using it would be, say for example, to go into cavity milling. We'll go and select a tool, we'll select the 16mm tool, we'll say OK, and quite simply we'll just press generate. If we do that, it's going to look at all of the parts and it's just going to try and machine it complete. Now in this particular case, NX is constantly looking at what's going on and making sure everything's okay. Gives a little bit of a warning to say that there's some areas have been ignored because the tool can't get into them. And I think that's intelligent, because obviously if we go into analyze and we're going to measure, we just zoom into there, we can see that absolutely that's got a radius of 3mm, and we know that the tool is a 16mm. So clearly we know it hasn't got into there, and that it just gave us a little bit of a heads up that that was the case. But the observance of you will notice that actually the tool has indeed gone into the vice jaws. That's because I hadn't told it to avoid them. So quite simply all we need to do is we can go into here and we can say specify the check areas. So these are the areas we want to check not to go into. So if I select those, I can say how far away from do I want to be, and let's say I want to be 2mm away from those, say OK, and now it's going to look at those, it's going to take those into consideration. Gives me the same warning as before because that still exists, that's still true. But now if we have a look in here, you can see that the tool actually stands 2mm away from those vice jaws and will never go anywhere within 2mm of them. But that's just machining the whole of the part all in one, not selecting any geometry, just said just go away and do it. We want to clearly be have a little bit more finesse than that, so let's just delete that and let's see what else we can do by selecting the true bits that we want to machine. So let's go and take a look in here at what we've got. So floor facing. Well, quite simply, what I want to do is I want to face mill across the top of the part. So quite simply, all I need to do is just do that. Just select the top of the part, say OK, and generate it. And that's it. It just faces across the top of the part. If we go back to the Home tab, we can turn on the in-process workpiece, press play, and we can see that just facing nicely across the top of the part. And if we don't want to do a zigzag motion, there's a number of different other strategy types for tool paths we want to use. Okay, so we've face milled it. What we're going to do now is I'm actually going to do a planar mill, and I probably wouldn't do this apart from to just demonstrate that we can. And that's what we're going to do in this case is something slightly different. We're actually going to not pick on the whole part. We're not going to pick on the faces, we're actually just going to pick on the edges. So quite simply what I'm going to do is I'm going to select where a floor is. So because this is effectively a 3D type, a 2D type method by just picking these edges, we have to pick the floor to define a depth, so we get the third dimension that's required. So quite simply what we're going to do is we're going to go into here, we're going to pick on the curve. I'll say it's going to be a tangent curve, select those, and the tool's going to be on the outside. So quite simply we can go into there and we can press generate, and that's it. It just very, very quickly and simply puts the tool path around the part. I'll just say OK to that. Now actually what I'm going to do is I'm just going to copy that and I'm going to paste it, because one of the things we can do, this is, gives us total control, is if I go back into this second one here, I'll just delete that tool path that was there before. If I just go into curves, I'm just going to pick a couple of these. I'm just going to pick these three. But it's a closed boundary, so what's actually happening is as it's going round, it's constantly trying to close the gap, and it gives me a warning to say that that's what it's trying to do. If I don't want to do that, maybe I want it to be an open bound. If I change that to open, that's exactly what it's going to do. It's actually now not going to try and close the boundary. So if I say OK to that and generate it, that's exactly what it does. It does the area that I asked it to do. The beauty of this though, however, is I can actually go back into there and I can go into my members list. I could go to this one here and I could say, actually, you know what? I actually want to start that all the way out there. And actually I could go to the final one and I could say, you know what, I actually want to pull this all the way into there. I don't know why, it's just to demonstrate that we can do it, and this is the strength of the tools that are available to you with the Solid Edge Cam Pro 2.5 axis milling. So there you go, you can quickly and easily move those about. Engage and retract, see these are blue, it's the cut line, the yellow is the engage. At the minute it's just going straight on. I'm not sure that's the right, what I really want to do, but you can see there's loads of different options available to you in your engage moves. So rather than the linear, let's go and change that to an arc, generate that, and now we get it nice arcing onto the part. Like I say, probably not a really sensible toolpath. It was just there to demonstrate that we could do that. So let's go away and delete that. We don't really need it. Right, now let's go and have a look at adaptive milling. So quite simply what we're going to do is going to go into the adaptive milling. Clearly I don't want to machine all of the part. I've already machined around the outside, and I don't actually want to machine into this pocket here. So what I'm going to do is I'm going to go into my geometry options. I'm going to say I'm going to use a trim boundary. I'm just going to select that as curves, pick that as a tangent curve. We're going to trim side is going to be on the outside, and then quite simply for my cut levels what I'll do is I'm going to say I want to machine from the top there down to there and just generate it. And you can see, there we have it, the adaptive milling toolpath. As I said, brilliant toolpath, really highly efficient. Now arguably, maybe I wouldn't, in this particular case I've set it to a step over of 35%. That actually might be a little bit coarse for what we're trying to do, because we're trying to go full flute, 95% of the flute. But I've done it at that so you can see the toolpath itself. Let's go and play what's actually going to happen in here. Quite simply we can play that. And so it tries to do a whole helical move out as far as it possibly can. Then when it can't do a helical move anymore, it then does nice looping moves in, trying to maintain the volume of material that's being machined. And in so doing, you're able to increase or maintain your feed rates. Sorry, because you're not gouging or you're not digging into corners and loading the tool up in corners. Okay, brilliant. So with that done, say okay. In fact, before we do that, we can actually go and do an analyze the toolpath. And what this enables us to do is it's got a nice colour coding of how much material is left on each of the faces. And in fact, if we click on the faces, we can see that there's 0.5 left on there, and there's 0.5 left in the walls. And actually, you can see there's a huge amount left in this corner. So that definitely needs to be taken out with a smaller tool. So let's do that next. Let's go and say OK to that. We'll go into here. So what I'm going to do is just going to go and specify the cut area. We're actually going to region boundaries. I'm going to pick that as the face. I'm going to pick that outer edge there, and I'm actually going to pick these as well, so it doesn't go anywhere inside there. I'm going to say OK, generate that, and because the in-process workpiece is turned on, it knows what material is still left to be removed, and it's gone and nibbled out all of the bits that were left from previously. Okay, so now we've got to that stage, we could go and finish this. So what I'm going to do is I'm just going to copy that and I'm going to paste it down. And I'm actually going to use my cavity mill, which you might think is a roughing operation, but I'm actually going to use it as a finishing operation, because what we can do is if we go into the strategy, we can turn on the finish passes. Now I'm actually going to change that to 0.5 millimeter, so we're going to finish with 0.5 mil. If we go back to the main tab, we're going to be doing 3 mil depths of cut, and I'll just go and check the geometry because we're going to have to change this stock to 0. If I say OK, that's exactly what it's going to do. It's going to finish it all now, finish the floors, finish the walls, and finish the whole of the part. Dead simple. Okay, now thinking about that, obviously we've got this cavity here that we haven't done. Maybe I could have done that earlier. So what we're going to do is let's go and create an operation. And actually I'm going to go back to my mill planar, and I'm going to use the planar mill again. If you remember, we did that for profiling round the part. And I'm just going to select a smaller tool. I'm going to use the 6mm tool. I'm just going to say OK. And what we'll do is we're going to specify the depth first of all. So if I just zoom in a little bit, I'm actually going to say I want to go down to there, and my boundary, I'll just click that to tangent, select those, there you go. Tool side's going to be on the inside. And what we're going to do with this is actually I'm going to change this to adaptive milling. So quite simply, when I generate this toolpath, let's just go and turn that off, turn that back on again, that's it. You can see that we've now got an adaptive milling toolpath, which actually isn't just using the solid model at all, but it's just using wireframe geometry. So you can do adaptive milling actually on the wireframe geometry. You can see the nice finish that you get with that one as well. Okay, so now we've got those done. We've done some milling using the whole part. We've used edges and we've used faces. What I'm going to do now is do some holes. So quite simply, I'm going to do some finding of the features. So this goes away, it looks for features on the part. Let's just close some of this down so we can see some of the options available to us. And we can find bosses, pockets, grooves, all kinds of features on the part. Quite simply, if it's found all those holes there, you can actually have a look in the feature tree, see what we've actually got. If we have a look on one of these, you can see it's actually an M3. If we look at the ones at the top here, it's actually found those as M20s. Quite simply, if we select all of them, all we need to do is say create feature process and say generate or OK, and that's it. It's going to look at the rules-based engine that we've created. This is out of the box, so this is what you get out of the box, no messing about. I've not changed this in any way or form, and it's automatically applied toolpaths to sensor drill all of the part, drill all the part, countersink those, thread mill those holes, and tap those. Really quite simple. If I actually go and generate, these ones here, I know it gives me a warning. It gives me a warning to say it hasn't been able to machine all of the holes because the tool can't get in there. So what I'm going to do is I'm going to select all of those, and actually not all of those. I'm going to leave that one there. I'm going to select these two holes here, and I'm going to drop those onto that chamfer tool there. So you can see how quick it is to actually move tools from one tool to another. So if I press generate now, it's a smaller tool. Quite simply, it's gone and done all of the tool paths. At the minute it's set, so it's going to go to the clearance plane. Now what we can do with that is, if let's just go into one of those holes, quite simply, let's just go to the options, let's just go to the non-cutting, and let's go and say transitions. And what do we want to do? We don't want to go to the clearance plane, we want to go to the lowest Z. Let's say I want to be 3 mil above. We'll say OK. And quite simply, that's exactly it. It's now changed to stopping at the R plane. So although it's been created using the knowledge base rules, it's very quick, easy to change it to whatever you want. So we've got all those done. Finally, what we want to do is let's chamfer the part. So let's go to create an operation. Let's go back to mill planar. Let's go to chamfer planar deburring. Quite simply, the tool offset is going to be down by 2 mil, and the chamfer we're looking to make is 0.3. So we're just going to generate that quite simply. NX looks at all of the part and puts chamfers on everywhere that chamfer is required. It may be that I don't want it on some areas. Maybe I don't want to chamfer the bottom. I'm not quite sure why, but quite simply I can say exclude edges, and if we go into tangent, select those edges, say OK, and generate. It misses those off. And you can see if we zoom in here that actually this is clear. It's not gone anywhere near that wall. It's gone as safe to that wall as our collision checking has allowed us to be. So that's it. That's created some toolpaths. Now, obviously, one of the strengths that we have here, one of the many strengths that we have here, is associativity. So if we actually go back to Solid Edge over here, let's just go into one of our parts. Let's just turn that stock off, and let's just go into just double click on that to make that active. What I'm going to do is I'm going to select maybe some of these faces here, and let's just drag that further down there so you can see that. Let's go and make that 15 mil. Okay, and let's go and take that one, and let's drag that one by 15 mil as well. So there you go. So we've changed those two as design changes. Quite simply, let's save and close that. So going back to the original design, what I can do is I could press the Cam Pro button to relaunch it, or what I can do is if I just save it in here first of all, I can go back to my Solid Edge Cam Pro, I can go back to my assembly, which is this one here, go back to my properties, say update file, and you can see the part automatically updated. It's given us a list of things that have changed. Say OK to that, and quite simply we can go back into here now and we can regenerate all the toolpaths in line with the change that has just taken place. So that demonstrates the full level of associativity that you're also getting between Solid Edge and Solid Edge Cam Pro. They're both developed by Siemens, so it all just works. Okay, with the toolpaths regenerated, the last thing we need to do is post-process. So quite simply, if we go into post-process, we'll select the machine we want, which is the 3-axis mill. We'll just say OK. And there's the NC code ready to go on the machine. Okay, so talking about post-processors, the big question is, how do you get them to actually that are relative to or right for your machine? Well, quite simply, you can come to us, we can write them for you. There are tools within Solid Edge Cam Pro for you to write your own. But on top of that, Siemens have also provided a library of post-processors for you to use. So if you actually go to post-process and you go to browse online for a post-processor, you've got to put in your login details that you'd use for your web key. But when you do that, you get to what's called the post hub. And you can see here that there's 1,244 post-processors available. A lot of them are free. Some of them are ones that are chargeable, but if I just select free and just apply the filter, you can actually see that there's 1,130 free post processors on there of all different types. Now we know that every machine tool is different, so even if you have got a machine, if I scroll down here, even if there is a machine, for example, like this one here, there is a strong chance that it will need some kind of modification. Again, you can do that yourself using the post configurator, or you can come to us. We've got a very professional post-processing writing team. The other thing I want to talk about, if I just cancel that, is training. So what can you do? Well, if you go into Discovery Centre, you've got this day one tutorials. So they do give you an idea, but I spent an hour's worth of tutorials just to give you a taste of what you can do and how things work. On top of that, we've set up some one-day training courses of Solid Edge Cam Pro Essentials that's been designed specifically for this particular 2.5 axis milling. So it's a structured online one-day course with a trainer. So it's got all the material there that you need. There's a trainer there to ask questions. There's going to be exercises for you to do as well to help you build up your skills. Okay, so with that, that's me complete. So I'll thank you for your time, and I will pass you back to Lee now. That'll give you some additional information. So thank you very much, everybody.
Thanks, Andy. It was a great demonstration. I'm sure everybody who's joined us today now knows the benefits of getting the Cam Pro. So I just want to touch a little bit on the licensing then and what we need to do in order to get this for you. So you need to be a maintained customer with a Foundation, Classic or Premium license. As I say, the Cam Pro has been introduced at the 2020 release. So we don't automatically add it to the licenses. So we need to hear from you if you're wanting to add this on. It's not an issue at all. We'll just send you a link. That link will generate a license to where the Solid Edge license is kept. You let us know where that is, send that back to us, and we'll add that to your current license, and we'll align it to your current maintenance. What we'll do from there then is regenerate it and let you know that when the license is ready, you can then get the license and the software, and it's available from the support centre. What I will do as well is send out a PDF to each customer with some information how to get those licenses, and also some information on downloading Cam Pro and installing that also. If you're a new customer, pretty much the same. Get the benefits of Cam Pro, purchase the license of Solid Edge, just say you want the Cam Pro add-in, and we'll do exactly as just explained. Again, for existing customers who are out of maintenance, if you come back onto maintenance, you can get the benefits of Cam Pro also. Just let us know. Once you're back on maintenance, we can add those licenses for you as well. So just wanted to do a section on our services here at 1PLM. Andy touched on some of the subjects with posts and training. I just wanted to recap a little bit on that as well. So we mentioned the Post Hub, where you can get a series of post processors you can download and use. They may not fit the bill 100% perfectly, but you can use them as a starting point. You can develop them yourselves with the tools within Cam Pro, or alternatively, you can come to us. We've got an excellent manufacturing team here, guys who are dedicated doing post-processor development. So we can either write those posts from scratch or take the posts you've currently got, develop on that. We'll look at that and give you a cost based on the work that's required, and then you will get a fully functional post from that. On training, we've got a number of training courses that we run for Cam Pro. I'm going to talk a little bit more we've got one dedicated to today's webinar. So there's a variety of courses you can take a look at on our website. So please feel free to do that. As well as that, we can offer bespoke consultancy services as well. So this could maybe on shoulder support or customization that you need to get your Cam Pro up and running exactly to how you want it to run. And then the final one is support. So as 1PLM customer, you'll have all the support channels available to you as well. So moving on to the training, we've got this dedicated one-day essentials course, which Andy touched on earlier. Highly recommend you take this course up. As well as the tutorials as a starting point, this is a more dedicated course around the 2.5 axis milling. Now you'd have a trainer available on hand on this course. He'll guide you through the Cam, and you will get the best out of this to get the best foot forward in using Cam Pro going forward. Now we've got some available dates on the 28th of March and the 11th of April. There is a cost to this, and it's a day rate, it's per person rate, and it's done remotely. But as I say, I can't recommend highly enough taking this course if you want to get the best out of the system going forward.